Section 5.3 is titled Rate of Change and Slope. So the first term is rate of change, and it is a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. So for rate of change, we have an equal sign, change in the dependent over the change in the independent. So here we have an example. The table shows the average temperature in degrees Fahrenheit for 5 months in a certain city. Find the rate of change for each time period. During which time period did the temperature increase at the fastest rate? So if you could copy that problem down, copy the table down. The first thing we need to do is identify the dependent and independent variables. So which one depends on which here? We have months and we have temperature. So the temperature is going to be dependent upon the month. So the month is our independent variable, and the temperature our dependent variable. And we do this because we need to remember which one's going to go over which when we write the ratio or find the rate of change. So let's determine the rate of change for each time period, which is what the original problem asked us to do. So the first time period we have is from month 2 to month 3. And remember, the dependent variable was the temperature. So it's temperature over month. And remember, it's a change. So let me actually rewrite that so that we are sure that we're doing some subtraction. So it's change in temp over change in month. So the change in temperature between month 3 and month 2, typically we subtract the first one from the second one. So 56 minus 56, and the third month, we subtract the second month from it. So we get 0 over 1, or 0. So the rate of change is 0 degrees in 1 month, or 0 degrees per month in this case. Now we need to find the rate of change from 3 to 5. And I'm not going to write this ratio again, so we're going to do 63 minus 56 over 5 minus 3. So 63 minus 56 is 7. 5 minus 3 is 2. So we get 7 over 2. And if we reduce that, or we write it as a mixed fraction, what this is basically saying is the change is 7 degrees for every 2 months. Typically when we're talking about rate of change, we change it to 1 month. So this would be 3.5 degrees per 1 month. And this one was, remember, 0 degrees per month. Okay, we have 2 more to do. We need to go from 5 to 7, and we need to go from 7 to 8. So from 5 to 7, it's 71 minus 63 over 7 minus 5, and that's 8 over 2, which reduces to 4, so 4 degrees per month. We always want the denominator to be 1. And then we have 72 minus 71 over 8 minus 7. So that's 1 over 2. Or excuse me, 1 over 1. So that's 1 degree per month. So we can see 4 different rates of change for the 4 different time periods. Some more vocabulary terms. The first one is rise, and in reference to slope, the rise is the difference in the y values of 2 points on a line. So if you're looking at 2 points on a line, how far are they apart in their heights? The run, in reference to slope, is the difference in the x values of 2 points on a line. So now we're looking at how far apart are they, the 2 points, from left to right. And slope is the ratio of rise to run for any 2 points. So the slope is the vertical change over the horizontal change, or the rise over the run. And I'm not sure why I have that one there twice. Not sure if I meant to write something else there or not. So let's find the slope of the lines. The first example here, we have our graph, and we have a line on it. So in order to find the slope, we need to find the difference in the rise over the difference in the run. And what we first need to do is identify 2 points on the line that we can label. And it looks like here we can label this point as 0, -1, and looks like we can label this point as 3, 3. So remember that slope is equal to rise over run. So we're simply going to count. How high is it from the first point to the second point? How far are we going up? And we can just count the units. 1, 2, 3, 4, till we get to the height of the second point. So the rise is 4. And the run, how far from left to right? So if we start here, we count over 1, 2, 3. So we have 4 over 3. So the slope for this line is 4/3. Remember, we're going to leave this in improper fraction form. Let's look at another example. Here we have a line on a graph, and we need to find 2 points that we can label. Looks like this one we can label as -4, -1, and this one we can label as 0, -2. So we want to figure slope again. It's rise over run. And if it helps, think it's y's over x's. The y's go up and down, the x's go left and right. So how high are we rising from the first point to the second point? Well, this one's going to be a little bit interesting because we can kind of go 2 different ways, but negative slope is something we do need to talk about. So if we're always going left to right, if I start here on this ordered pair, -4, 1, I'm actually falling 1. I'm not rising. I'm actually falling. So we're going to call that our -1. Then how far from left to right? Well, we go 1, 2, 3, 4 over to the right. So it's -1/4. Now, you could also look at this a different way. You could start at this ordered pair, and we do go up 1, but since we're going left, then that's where you would take into account the negative. So you would get 1 over -4, which is still a -1/4. And this leads us to the next discussion, the different types of slope. So please write these down. You don't have to write the words down along the bottom, but please write the description and then draw a quick graph. So positive slope is a line that rises from left to right. A negative slope is a line that falls from left to right. So it's kind of like uphill and then downhill. Zero slope is a horizontal line. And you can think about it just being really flat. There's no change in heights, so it's zero slope. And then undefined is a vertical line. And often those last two can be mixed up, so try to keep them straight. Zero slope is a horizontal line. Undefined slope is a vertical line. So now for the last few examples, we simply want to tell whether the slope of each line is positive, negative, 0, or undefined. So for number 4, we have a line that's rising as we go from left to right. We're going uphill. So this is positive. And if we go all the way back to that very first example we did to find the slope, notice this line also rises from left to right, and our answer was positive. Number 2, we have a vertical line. So go back and look at your notes from the previous slide. A vertical line, the slope is undefined. And we'll explain a little later why it gets that category. Last two examples, we have a line now that's falling from left to right, so we're going downhill, so that's negative slope. And number 7, we have the horizontal line, which indicates 0 slope. And if you look at example 6 again, and we go back to the one where we were calculating slopes, notice this line is falling from left to right, and it did in fact have a negative slope, negative 1/4. And in class, we'll work on worksheet 5.3.